In 2018, master's student and former cook Robin Sherriff started a dissertation. The subject was alcohol, and it led him all the way to Japan.
Just round the corner from where I lived in Kyoto, there was a sake brewery. Sake is fermented rice. Sake is incredible. It's my favourite drink in the world. The brewery had been in the family since the 1700s or something. And I just knocked on the door one day because I was like, I need to add something to my thesis. And the guy turned up at the door. He took me in, and it was a brewery. It was the same big steel tanks, the same white wash clean floors, loads of guys in white Wellington boots.
So far so familiar, but up a staircase was a room full of surprises. This was the Koji Moro, the Koji room.
I'd never heard this word koji, and this is the heart of the sake brewery. This is where it all comes from. And so we went up the step ladder to what looked like a massive submarine door, a massive circular door. He pulled it open, and then I was met with this like beautiful, thick, chestnut, sweet smell. And then I saw this cedar-clad room full of wooden trays and trays and trays of mouldy rice. Like big fat cakes of rice with mould all over them. I said to him, I was like, what am I looking at? What am I seeing here? He was like, oh yeah, this is koji, this is rice. We cook it and we leave it in a warm room at high humidity for days. And my immediate thought was, as a food professional who has worked under Western dogma, you're going to die. What are you doing? This is Bacillus cereus central. You're going to kill yourself with enterotoxin. And he was like, chill out, don't worry.
The few minutes Robin spent inside that room filled with cakes of mould-covered rice changed his life, sending him on a journey from sake brewery and onto the complex and curious world of koji and miso, and a deep dive into microbes and an obsession with fermented foods.
I have absolutely no history and no culture in fermentation whatsoever. I grew up in Livingston, which, if you're from Scotland, you'll be very aware, certainly in the 1990s and 2000s, was not a great place. Certainly not a hub of food. I grew up eating fish fingers and drinking Buckfast. So I actually don't have any of this cultural connection with fermentation, which many people do. I don't have that. But what I did get was, thankfully, scientific understanding. And I imagine there's a lot of people like me who don't have this link with food or have had that link severed. So how can we connect with it? And for me, it was through science.
Over the years, we've made many programmes about fermentation, from its role in the production of chocolate, cheese, coffee and beer, to how-to guides for sauerkraut and yoghurt. And we've delved into the history and culture of kimchi and kombucha. In this edition, we're peering more intently through the lens that Robin found so fascinating. Fermentation science. We'll be looking into the processes that take place when foods are undergoing fermentation, and how these foods go on to interact with our own microbial inner worlds, our gut microbiomes, resulting, we're told, in health benefits. To tell this story, we'll hear from 3 different fermenters, each one a science communicator, each with their own area of expertise, and even favourite definition.
My definition of fermentation is living stuff breaking big stuff down into small stuff.
My own favourite definition of fermentation is that it's a transformation process. It's a transformation of a food using microbes. You give the microbes a source of food, those microbes eat that food, and in doing so produce a load of other things that are beneficial to us.
In many ancient traditions, people used to think it was a magical type of cold cooking. They used to see this boiling mass. How could you get bubbles coming out for something without heat? So they thought it was some mysterious energy source in that food that you were cultivating.
That last voice belonged to Professor Tim Spector, epidemiologist, pioneer of a groundbreaking study into identical twins and their health differences, and one of the most influential communicators in the UK on the science of the gut microbiome, the trillions of bacteria, fungi, archaea and viruses we all host, which we now know play a role in our physical and mental health. And Tim has been helping us to tell that story on the food programme for a while now.
Basically, I've been handed from a very bloody knife a little slice of liver. It's a very delicate flavour.
You might remember, a few years ago, Tim travelled to Tanzania to investigate the microbes inside the stomachs of some of Africa's last hunter-gatherers, the Hadza.
We now clearly know from many population studies that there's a link between the greater diversity of species in your gut microbes, and the Hadza average microbiome had 40% more species than we have in the UK. Many rare ones, many have gone extinct in European populations. These hunter-gatherers appear to have the most healthy microbes on the planet. So it's very exciting to come here and actually try and work out what can we learn from them before they and their microbes go extinct.
Following on from Tim's research in Tanzania and his books on the gut microbiome, among the questions that kept coming up from Tim's readers was, are fermented foods good for my gut microbiome? And if so, why?
And because I wanted to respond scientifically, I started doing more research myself into ones that maybe I hadn't tried before, more obscure ones, things like kombuchas and kimchis and miso pastes and many other ones that I'd never heard of. And so I realised there was a whole other world out there that most people weren't aware of, and most of these hadn't been connected to actual science.
Why is it a difficult area of research?
I think there are a number of reasons that fermentation research has been slow to take off. And the first is that it's seen as a rather fringe or alternative area. So serious scientists, serious geneticists, microbiologists really haven't paid much attention to it. Second is there's not much money in it, very hard to get any grants. And the other thing is that we didn't really have the technical skills to do it very well. So you've got to remember that the ability to look at the microbiome depends on our genetic techniques. And so the genetic revolution was needed before we could actually start studying this properly. And until very recently, we've only had crude measures of what the microbes are in our foods. And this has only really changed in about the last 5 years, where we were able to get what's called shotgun sequencing and look at every gene in every bug in our food. Before that, we were just summarising it or making very broad statements about it. So a combination of factors, really sort of cultural and scientific, led to it really being an obscure topic that people just didn't think was going to deliver much.
A lot of what we now know about the recent science of fermentation has been brought together in Tim's latest book, Ferment, the life-changing power of microbes.
What we can say has really changed in the last few years, and that's why I wrote the book, because 3 years ago, a crucial study came out from Stanford University in California, where they followed 28 people really with daily blood tests for 6 weeks, and they were giving them 5 fermented portions a day, different ferments, and they showed about a 30% reduction in their blood inflammation levels.
Tim will expand on his use of the term inflammation a little later, but for now, think of this as a chronic and unhealthy response by our immune systems, a response that's possible to identify by monitoring specific proteins.
This wasn't just one marker, this was like 75% of all the proteins they looked at. And they looked at over 20 different inflammatory proteins. And this effect also improved their gut microbes, so their gut health improved. And that was more than the control group, which were just given high-fiber diets. These fermented foods were having not only an effect on the gut, improving your gut health, but a very direct effect on your immune system. And that links in with all these little studies over the last 20 years that have showed that people who have regular fermented foods have less common diseases, they have less heart disease, less diabetes, less autoimmune disease, less allergies. And short term, you can improve things like irritable bowel syndrome and many common complaints and even mental health. So,
how can you explain that? You talked about fermented foods have been shown to improve general mood as well as specific conditions, including anxiety and depression. How?
We don't know the exact mechanisms, but again, the immune system is coming into play here. The new way of thinking about things like depression, anxiety are that stress levels in the body upset the immune system that then causes inflammation. So that in the blood, you've got these inflammatory proteins which are just burning, like you left the gas burner on slightly overnight. Rather than turning it off, it's just on slightly and it's on all the time. Your brain picks up these signals because there's a big connection between the brain and the gut. It's called the vagus nerve, and there may be other ways of connecting. It then thinks it's unwell and therefore needs to, in a way, shut down the brain. That's this current idea that this gut-brain link is through inflammation.
That axis between our guts and our brains is fascinating, and we're starting to discover more about the mechanisms by which powerful chemical signals triggered by the food we eat, including complex fermented ones, are sent through our bodies.
So another pretty recent discovery is that we have these neuropod cells in our gut lining, and these are specialized at sensing what foods are being ingested by microbes and what chemicals are being produced. So we have this vast relay system that can rapidly alert the brain in milliseconds about whether good or bad nutrients are coming its way. We're realizing that actually these nutrient sensors throughout our body are incredibly important, and we're just discovering that they're in more and more places we hadn't thought about. And it's showing just how important they are for our metabolism, but they're becoming increasingly important for things like aging as well. And so many of the new anti-aging treatments are targeting these nutrient receptors, which just show how vital it is what we put in our mouths and in our gut have these huge effects across our body.
We'll hear more from Tim Spector later on what exactly happens when we ingest fermented foods and if they really are beneficial to our health. But let's go back to Robin Sherriff, who, as we heard earlier, became obsessed with fermentation after seeing a room full of koji, the rice inoculated with mould. He's now a professional fermenter based at the Midlothian Innovation Centre on the outskirts of Edinburgh, which is where I went to meet him.
Okay, Robin, so we're on a corridor in a building, I don't know, 1950s building? Or?
I think it was 1960s. It was the old National Potato Lab of Scotland. It's where all the research was done on potatoes, and it's where all of the seed potatoes were stored, just in case there was a blight. There was a lot of potatoes in here.
So there's a lot of food and farming history in this building. You moved here 3 years ago and were outside a set of doors and a sign that says Koji Kitchen Fermentation Lab. Take us in.
Absolutely. It's sort of a cross between a professional kitchen and a laboratory. So we have big steel tables, but then we have things like incubators. We have small incubators, large incubators, which basically hold different ferments at different temperatures and humidities very specifically. Then we have things like dehydrators. We have massive industrial steamers. But beyond that, I have a koji buta, which is a traditional cedar wood tray in which you would ferment koji. And we have a 100-year-old sauerkraut press and various other weird bits of equipment. But that's what we're looking at.
Robin's work and his new book, The Science of Fermentation, explores all forms of fermentation, from the role of lactic acid bacteria in making sauerkrauts and kimchi, to the action of yeasts in making different alcoholic drinks or loaves of sourdough bread. He experiments with acetic acid bacteria to create vinegars and makes use of the bacterium Bacillus subtilis to produce the spider's web-like slimy biofilm that knits soybeans together as natto. His real passion, though, remains koji.
After that day, when I learned about koji, I just got obsessed with it. Like, it wouldn't leave me. I just couldn't stop thinking about this mold ferment. I couldn't stop thinking about how interesting it was. So I read extensive amount about this specific microbe, Aspergillus oryzae, and the different processes that were used to make sake and make miso and make shoyu. And then after a year, I went back to Japan specifically to learn about koji.
And in the lab is a large container of koji he's just made. At first glance, it looks like powdery rice, but on closer inspection, there's more to this creamy-coloured, dry, crumbly substance. The rice appears to have been transformed by the mould. But how?
The same as a mushroom, it forms these little stalks. It forms little stalks with little heads that produce spores. Same thing, but just on a very, very small level. And it creates little roots that go through the food. And it creates these little roots. These little roots are hyphae. As they grow, they create things called enzymes.
Enzymes?
It's essentially a biological key to a lock. Breaks a big thing down into a little thing. When I say breaking a big thing down into a little thing, a big thing would be something like a starch. We find tons of starch in rice. So that starch gets broken down into sugars. Those sugars can then be fermented by something like yeast into alcohol. And that's how you make sake.
Just to get to this stage, the making of the agent that is koji involves a precise and skillful process.
Rice is washed very carefully, then drained, then soaked overnight. After soaking, it's drained once again. Then it's steamed. After steaming to a very specific texture, after you've cooked the rice and cooled it down, you inoculate it. So you dust it with a very specific kind of mold culture. This is Aspergillus oryzae. After you've dusted, inoculated this rice, this cooked rice, you pack it into different trays and then you incubate it. And when I say incubate, you hold it at a very specific temperature, very specific humidity, depending on what qualities you want. Because if you vary it at this point, you can fundamentally change the flavors that you get at the end. And that is allowed to ferment in a chamber for about 12 hours. After that, the koji, the mold, and the rice becomes exothermic. Now, when I say exothermic, that means it starts to produce its own heat. And it can get so extremely exothermic that it can actually kill itself. So it can punch up to 45, 50, 60 degrees. Yeah. Which is, that seems insane for just a natural process. It's just microbes breaking stuff down, and it can get that hot and still be alive.
Broken up, aerated, and cooled, the inoculated rice can then be used to make a very wide range of different fermented foods and drinks.
It's not just sake. It's used in miso. It's used in soy sauce. It's used in dobanjang.
A Szechuanese bean sauce.
It's used in gochujang.
A sweet, salty, spicy Korean chili paste.
During the course of that mold growth, as it put through hyphae, which is essentially roots, the starch is broken down into sugar by a thing called amylase. That is the enzyme that operates on yeast. But beyond that, we have two other enzymes. Now we have lipase, an enzyme that breaks down fats. Now it breaks down fats into things like butyric acid. That's what basically makes parmesan smell like feet. That's butyric acid. And that happens because of naturally found lipase within the cheese making process. The One that I'm particularly interested in, that I really care about, is protease. Now, this is the enzyme that breaks down proteins into amino acids and peptides. We hear amino acids and we think about like DNA, we think about like the building blocks of life. But the thing is, amino acids are flavor, so are peptides. These are the things that give you the umami response. That's what we're tasting, because essentially human beings are like bioavailability detection machines. So our bodies, the reason we have an olfactory response, the reason we have a taste response is our bodies want to find the easiest and most efficient way of finding calories and nutrients. So if we taste something that is a protein that has already been broken down, that means we can very easily digest that. And that's why it tastes delicious. That's why it gives us this umami response. That's how you can turn something that tastes as bland and as boring as a soybean into miso paste. Delicious umami miso paste that makes, your miso soup. That's what makes soy sauce delicious.
How do you get from this to miso?
What we do with this is mix it with soybeans and salt. After that, it's all mixed together and then it's run through a grinder. Then that is packed into some kind of bucket or barrel, and it's left to ferment for 6 months, 12 months, up to 3 years.
You have some here?
Yes, I have lots.
Which you're going to have a look?
I have.
And by lots, Robin is referring to the diversity of what he makes as much as the quantity.
It doesn't care if you're trying to ferment a soybean or rice. You can ferment anything. You can utilize these same techniques to turn oats into miso. You can turn Carlin peas into miso.
And in a collection of tubs, Robin shows me the end result. Thick, shiny paste, some dark, some light, and all incredibly intense in their flavour, which isn't just down to the mould and enzymes.
Things like lactic acid bacteria, whilst we're more familiar with those working with sauerkraut and kimchi, they're at play in a miso as well. That's what adds in this gentle acidity. That's also what adds in more complexity. And then you have things called halophilic yeasts, which are essentially, it's just yeasts that can deal with salt. So not brewer's yeasts. They're more similar to sourdough yeasts, but it's yeast, essentially. Over time, they start to produce things like aromatic compounds, which is what brings miso its wonderful complexity. So why I think the miso process is so wonderful is it's like a microbial symphony. There's lots and lots of different microbes all playing together all at the same time.
Is there anything particular or specific about this approach to fermentation on our health?
Digestibility. The key benefit of something like miso is that basically microbes have already done the job. They've broken stuff down already. So it's much, much easier for you to digest, and it's much, much easier for the microbes, the commensal and symbiotic microbes that live in you, to eat this stuff. So it's rather than it being the live microbes you're consuming, it's the work that they have done already by breaking things down.
And with a bowl of miso soup made with Scottish oats, I sit down in the lab to a breakfast filled with brothy umami flavours, a warming, nourishing and surprisingly filling meal. You start the day with this?
Every day. I mean, it is a traditional Japanese way to start the day, but it's not because I'm paying credence to that. It's mainly because it's just tasty. It's just really tasty.
Robin Sherriff, koji maker and author of DK's The Science of Fermentation. Let's turn from moulds and miso to another category of ferments, those made through lactofermentation, utilising the powers of lactic acid bacteria, the ubiquitous microorganism that finds its way onto and into everything from soils and plants to the surfaces of fruits and vegetables. But the specific example we're going to explore is a dairy one, milk kefir, with the help of another expert who has a deep interest in science, Dr. Caroline Gill-Martin.
Many, many years ago, I got a PhD in molecular genetics. When I came to get fermentation in my life, if you like, I hadn't been being a scientist for a very long time, and it is actually fermentation that brought me back to science. Now, when we talk about fermentation, it's probably just a good thing to step in here and say fermentation is a process of enrichment of food using microbes, really. So you're making nutrients from microbial action. So you must have microbes there to do the fermentation. And there are lots of different fermented milks in the world, probably like over 1,000. Loads of different cultures have different fermented milks with different microbes involved. But kefir is made using something called kefir grains.
An important point of clarification here. Kefir has nothing to do with the grains you might be thinking of. What Caroline is referring to is a much stranger substance and agent of transformation. In front of us, she placed a jar filled with thickened milk, within which were the so-called grains.
So this is my milk kefir. It's been sitting on the work surface for 24 hours and I'm now going to strain it. So all I'm going to do is I'm opening the jar and I am tipping my milk kefir into a straining funnel, which is a sieve atop a funnel. This is what makes kefir. This is the microbes stuck together in their matrix.
It looks like cottage cheese, but then you play around with it with the
literally
spoon.
like
and
rubber.
It is like rubber.
It's like rubber, and it's polysaccharide called kefiran. It has never, ever been recreated in a laboratory. Nobody has ever managed to artificially make kefir grains. So all kefir grains are children of kefir grains that were originally grown in the Caucasus region, which I absolutely love.
So this event happened to produce the agent, which then has lived and been shared and spread around the world.
A couple of thousand years, yeah. And it's basically a biofilm of bacteria and yeast living together in happy harmony. There are between 25 and 45 different types of microbe living in there. It's hard to say. Different kefir grains evolve differently over time, but pretty much what those microbes do, a lot of them are lactobacillus microbes. They are able to use the lactose in the milk and convert that into lactic acid, so that sours the milk and makes it taste slightly yogurty. So it's a soured milk product into which you have grown a massive population of lactobacillus and other associated microbes, and you've got all of the end products from their metabolism in there. So lots of metabolites that are also very good for your health.
And there's another interesting feature of kefir to be aware of. It appears to be the ferment with the best stories.
People have known about kefir grains for a very long time, and it appears that they did arise in the Caucasus region between Georgia and Russia. And the story goes like this. People would go and look after their sheep in the fields, and they would take milk for the day in a goatskin bag. Sometimes during the day, the milk would turn fizzy and sour, and the people would think it was delicious and they'd feel amazing when they had it. And then an association was made between that happening and these funny little white globules that occurred in the bag when they emptied it out, hence kefir grains. Now, things went on like this for quite some time and they kept them to themselves. And then in 20th century Russia, at the beginning of the century, people kind of got wind of this miraculous cure of the Caucasus, and doctors were very keen to get their hands on some milk kefir for their patients. And they talked to a local dairy to see whether they could possibly produce some of this kefir. And the local dairy said, well, yes, we could, but we need some kefir grains. And so they actually sent a young, beautiful scientist to charm one of the local princes of the Caucasus region to give up some of the kefir grains to bring back to Russia so that they could start making kefir.
Like fermentation espionage.
Exactly. But there are all these kind of stories around saying that, oh, he kidnapped her and then he wanted to marry her, and you can embellish it however you like. But at the end of the day, he was charmed. He gave her kefir grains. She brought them back. They started making kefir. And for a long time, it was given to patients in hospital.
Is this still milk? Do I refer to it as milk? Or
no, we call it kefir now. So when it's soured, we call it kefir. When it's thickened and smells sour, that's when it's ready.
Can I have a sniff?
Yeah, of course you can. I'm going to taste some too.
Thank you. Yeah, cheers. Yeah, it's kind of a gentle lactic soundness.
Yeah.
It's almost a really milky, yogurty drink.
Yeah.
Sometimes is it more effervescent?
Yes. If I'd have cultured that for longer, it would be stronger and would have taken on a slightly fizzy edge.
Really pleasant sharpness, almost lemony edge to it.
And I enhance that further by putting a little bit of lemon zest on it quite often.
So that's now going into my digestive system.
Yes, it is, where it's going to hopefully stimulate some of the helpful microbes in your gut to grow more effectively than the less helpful microbes in your gut, plus provide you with all kinds of end products of their microbial metabolism and breaking down that milk into short-chain peptides, aryl lactates, all of these things that will help to improve the health of your gastrointestinal tract.
And what milk do you use?
I use organic whole milk. You can use any milk you like, and you can even use lots of not milks. You can use soya milk, and you will actually get a set product because soya contains lots of different amino acids that can kind of form the right sort of curd. The reaction happens at room temperature. It's very easy to do. Usually you'd make a batch of kefir within 24 hours. So you put your microbes into the fresh milk. They're aware that there's a source of lactose there that they can sense, and they start metabolizing that lactose and they start to break it down and they produce lactic acid and a load of other things besides, lots of vitamins, lots of other enzymes, plus those microbes are growing as well. So you've got all of those metabolites they make plus the microbes going into this thick, set, almost drinking yogurt.
How do you imagine it? I mean, obviously, you're coming at this now with a scientific viewpoint, but do you have an image in your mind of what's unfolding in the jar? In that, is it the idea of some things are eating other things, or breaking things down and then releasing?
That's exactly it. And also the microbes talk to each other. They talk to each other in a language that we are only just beginning to understand. And these microbes in my kefir jar, when I eat the kefir, they are also talking to my own microbes in my gut. So there are lactobacilli in this jar that can persist for a short time in the human gut, and they are constantly sending messages to the microbes in my gut.
You could break it down to its component parts, but actually the outcome of this process of fermentation is greater than the sum of its parts because of that chemical signaling. The output of that conversation of those chemical signals creating something new in that environment.
Yeah, I really like that description. And also it's a little bit like people are always trying to put probiotics into capsules and then say, oh, just have this capsule. But you're missing 2/3 of the story, because you're missing the fact that you've got this community of microbes actually that have grown up together, that are talking together all the time. You're missing all of their end products of metabolism, and you're missing the milk that was a good thing to have beforehand, but is now full of all these additional nutrients that you could be having. So if you could choose a probiotic capsule or some milk kefir, just have the milk kefir.
Before I left, Caroline gave me some kefir grains to take home so I could start to build up my own home supply. Thank you, Karen, and I will let you know how I get on.
You're going to get on marvellously.
I will look after them. Dr. Caroline Gilmartin, who became a kefir convert following a period of illness which lasted from her PhD years and into her 40s, during which she was encouraged by a friend to start taking a daily dose of the fermented drink. And Caroline is convinced milk kefir played an important part in her recovery, and evidence of kefir's health benefits is growing. There are years of studies, admittedly small scale but multiple in number, that point to positive effects, including blood cholesterol, blood sugar, blood pressure, weight and inflammation, increases in serotonin levels and gut microbiome composition. More research and larger scale studies are needed, but it's also worth noting that in the 2022 Stanford study, Professor Tim Spector highlighted earlier, which linked fermented foods to improved immune systems and a reduction in blood inflammation, the most common food featured in that study was kefir. Now, to round things up, let's go back to Tim. I wanted to know if we are any closer to understanding the exact mechanisms that turn a mouthful of fermented food into a health benefit.
So in the past, we were pretty unclear about how fermented foods worked. We thought that they would act to colonize the large intestine and sort of take over the gut. But now we know that they'd be so outnumbered in the large intestine that is highly unlikely, because we're talking, they're competing with hundreds of trillions of microbes. They wouldn't be able to get any real influence down there. We think what's happening is now they're having their main influence higher up in the gut, the small intestine, where a lot of the immune cells are. So there's less competition from the residents, and so the fermented food microbes can land on immune cells in the small intestine, and that's how we think they have their major effects, by ramping up our immune system so that it's much more responsive, much more flexible. It means it's better at fighting aging, fighting cancer, fighting infections, preventing allergy and autoimmune disease, all the things that we know fermented foods can do when they're taken in large amounts. So this is the new science of what we think.
What do we think the mechanism might be? What is the interaction creating?
Well, we think that these microbes are tickling the immune system. The immune system is interacting all the time along our gut lining with our microbes, and it's essentially looking for signals. And so what these fermented foods are doing is targeting particular immune cells, we think, and this giving them good signals, giving them reassuring signals to say that, these are good foods coming your way, these are healthy, let's send out healthy signals from the immune system to the rest of the body. And so once the immune system has done that, it will send out signals to say, for example, let's reduce stress, let's reduce inflammation, which is the ramping up of the immune system. Let's calm everything down through this particular mechanism. So this is what we think at the moment is the way it acts. And increasingly, the immune system seems to be the way the microbes are interacting with the rest of the body. And the immune system is, like the microbiome, absolutely crucial for how all diseases start to occur. We know that in the West, we have these immune systems that are just heightened all the time, whether it's due to stress, whether it's due to bad food, pollution, lack of exercise, whatever. So we're always looking for new treatments to improve that, and fermented foods tick all those boxes.
Another surprising feature that's emerged from recent scientific research revolves around the question of, does a fermented food need to be alive to give health benefits? And the answer appears to be no. It's even led to a new term.
Postbiotics is an important concept because it can be any mixture of whole or fragments of dead microbes, or their compounds, or even the liquid they produce. So these are dead microbes.
Yeah, you'd imagine that a dead microbe is a redundant microbe. It's having no impact.
Well, that's exactly what I thought 3 years ago. And I was ready to write off any sort of pasteurized ingredient, any sourdough that'd been stuck in the oven. All of this I thought had no real health benefits, because it seemed to be pretty clear that if you kill off a microbe with acid or heat or in other way, it's going to be useless. But I was wrong. And science has now showed time after time, at least 20 studies, showing that dead microbes have a health benefit. And
how?
It is quite amazing.
Yeah.
So we think the mechanism is similar to that of a dead vaccine. So if you think about your flu shots or some of the COVID shots, they were given with a dead or attenuated virus. And so all you've got is the protein wall of that microbe and the proteins that are sticking out from the cell wall, but actually it can't replicate. But what we think it's doing is these so-called postbiotics, I like to call them zombie biotics, are going into your gut and they're tickling your immune cells. Again, we talked about in the small intestine how you've got not much competition and you've got lots of immune cells. We think they are tickling them in some way and sending signals to the immune system that actually this is a healthy signal. That's our best guess at the moment to explain these extraordinary findings that have been replicated many times. And I think it's going to revolutionize a lot of our thoughts about fermented foods. Danone have recently bought a dead form of Akkermansia that they'll probably be putting into yogurt soon, because the regulations around putting dead microbes in food are very light indeed compared to live ones, because people were very worried about unknown live microbes that we hadn't studied before getting into food and then, in a way, taking over our guts. So this could be a real important therapeutic way of actually changing our immune systems through food.
Professor Tim Spector on some of the revelations from recent scientific research into fermentation, a subject I'm sure we'll be returning to again and again for reasons of taste, for stories of history and culture, as well as our health. Now, let's get these kefir grains to work.